All right, we have practiced writing equations in two variables. We have practiced solving equations in two variables. We have determined the difference between independent versus dependent variables. And today is the day that we put it all together. All right, so these problems are a lot longer. You will be asked to do a lot less of them. We are going to go through one example. Please remember to pause or rewind. Take your time. These should not go quickly. We will move through them at an appropriate pace. Don't rush. Are you ready? Let's do it. Alrighty, our example is that Tommy mows the lawns on the weekends. He earns $4 per lawn. The amount he makes depends on the number of lawns he mows. All right, so we got to break that situation down and go ahead and write it into a mathematical equation. So let's start off with our word equation. What is the story here? Well, he mows lawns, correct? He makes money per lawn mowed. And that is multiplied, whatever he makes per lawn is multiplied by the number of lawns mowed to get us a total amount of money he makes. Okay, so he starts off with a price per lawn. Then he multiplies that with the number of lawns that he actually mows to get the total dollar amount that he makes from mowing lawns. So we got to determine which information we have, and we only have one little piece right now, which is that per lawn he makes $4. We do not know how many lawns he mows, and we do not know his total money amount. So we need to make let statements for each of these. So let's go ahead and say, let M be lawns mowed. And let's do let A be amount made. Remember, your let statement does not need to look like mine. You can use different variables, what makes sense to you. Let's go ahead and take this and turn it into our mathematical equation. So I just go ahead and bring everything down. 4 times M equals A. Or I can simplify that down. So my equation is 4M equals A. $4 per lawn multiplied by the amount of lawns he mows equals the total amount of money Tommy makes. Before we go any further, let's go ahead and determine which is the independent variable and which is the dependent variable. The independent is the one that can stand on its own. It can change as it needs. In this situation, that would be the lawns mowed. Tommy can increase or decrease the amount of lawns he mows freely. If Tommy's out of town or it's a holiday weekend or whatever the case may be, he can increase or decrease this number. The dependent variable is the money made. Tommy can say he wants to make a certain amount of money, but that money has to come from the number of lawns he mows. This cannot change. If he decreases his lawns mowed, this cannot increase. Does that make sense? If this decreases, this can't increase. These have to move together, or this has to move with this, excuse me. All right. When we have our equation, like we do here, our dependent is going to be after that equal sign, right? Our independent can change, but that will impact our A here. All right, let's get on to our problem solving. We are going to use this equation as we move down here, it says if Tommy mows 6 lawns, he is mowing 6 lawns. How much money will Tommy make? Again, I'm going to use my equation. I've got 4M equals A. Now, lawns mowed, that is my M. So I go ahead and substitute in. 4, substitute 6 in for M, equals A. I simplify it out. 24 equals A. Well, what is A? A is the amount made. Tommy makes $24 if he mows 6 lawns. And there's our first problem. Now we have if Tommy makes $36, how many lawns did he mow? Again, we need to use our equation for M equals A. Our equation is not changing. What's changing is our variables, what we substitute in for our variables. So here it says that he makes $36. That is the amount made, which is our A. So this time we would plug 36 in for A. For M equals 36. Well, I know that to solve this, I need to get that variable alone, so I divide by 4. M equals, well, 36 divided by 4 is 9. So Tommy mows, that M means the lawns he mowed. Tommy mows 9 lawns if he made $36. So we used our equation all the way through. Now, we didn't forget about the importance of our independent and dependent variables. We're going to use those on the next page. So don't lose this, but let's turn it over. All right. So now we're going to use a table to fill in a larger amount of data, okay? So we remember that our independent variable is our lawns mowed. That can change. This changes based on this. So this is our money made. Okay, so now we need to pick some values. So we can pick any values that we want to go in either side. Then we just go ahead and determine what our opposite values. So our table has to match. So I'm going to go ahead and say 2, 5, 6, and 9. Okay, so I'm still using my same equation here, which is 4M equals A. So this is my lawns mowed. This is my M for my X, okay? And this is my Y or my A. Okay, so lawns mowed, if I plug in 4 times 2, that will equal 8. So my dependent, my Y or my A is 8. I would like to back up for just a minute. My independent will always be X and my dependent will always be Y. If I go ahead and substitute in other letters, that's totally fine. Or I can use those X and Y for my independent and dependent every single time. It kind of is your choice. Okay, so I go ahead and plug in my M again. 4 times 5 equals 20. 6, 4 times 6 equals 24. And then I've got 9, 4 times 9 equals 36. Okay, so these are our ordered pairs, actually. These numbers go together with this equation. This ordered pair together will make this equation in 2 variables true. I can't have 2 and 9. That will make this false. These make it true. So what happens is that I can take my different ordered pairs that make my equation in 2 variables true, and I can plug it in to a graph. All right. So when we are graphing, our X will always be our independent variable. Okay, so in this case, that would be lawns mowed. And I am going to go ahead and label that. Always need to label our graph. Lawns mowed. Okay, then your y will always be your dependent. In this case, that means money made. Now, you need to go ahead and make sure that when you're labeling your graph now, that you are making sure to use consistent measurements. So for example, up here in my graph, I counted by 2, 5, 6, 9. That's not a consistent count by. That's not equivalent. So what I need to do is I need to pick something to count by down here. It's got to be equally spaced. Okay, so I can't just count by 2, 5, 6, 9. I need to pick something to count by and count by it. So let's go ahead and we can just count by ones here. I think it's also important to note that sometimes, depending on the values you pick here, you will not always be able to graph everything. You do want to try. I have 2, 5, 6, 9 all in my graph down here. I was able to fit them all. Sometimes you won't be able to, but you should try to get at least 2 to 3 of your points in the graph. Here, we've got 8, 20, 24, and 36. So I'm going to count by, let's count by 5s. Let's count by 4s. Ready? Let's do 4, 8, 12, 16, 20, 24. Okay, so I want to point out that your count bys here don't have to match your count bys here. Okay, so that's okay. They don't have to match, but this has to go up incrementally and this has to go up incrementally. Okay, so then I take my ordered pairs and I graph them. I've got 2, 8 to start. So I go over 2 and up 8. Then I've got 5, 20. 5, 20. Then I've got 6, 24. And lastly, I have 9, 36. Now, with this, I should have a straight line. My line should go through 0 and create a straight line showing me actually some other ordered pairs that might make my equation true. So for example, 1, 4 would make my equation true. What else do we got over here? 10, oh, I didn't go up high enough. 40 would make my equation true. So if I plugged in 10 and 40 in that ordered pair into this equation, that would make it true. So like I said, one big problem, putting all of our pieces together. Our goal is to be able to see all the different ways that make our equation true. What are all the ordered pairs that we can find to make our equation true?